Hello, good afternoon. I am audible.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Hello, I am audible.
Yes, sir. Yes, sir.
हिमांशु यादव.
Yes, sir.
हिमांशु आपकी आवाज नहीं आ रही है.
Yes, sir.
Yes,
Is I am
sir,
audible?
you are audible.
हिमांशु, you are not audible.
Excuse me, sir. I am audible.
Rafiq Ramadan.
Yes, sir. Am I audible?
Rafiq Ramadan.
Yes, sir. Yes, sir.
Rafiq, open your mic. You are not audible.
Mic is open, sir. Am I audible, sir?
Again, not audible.
Okay. Excuse me, sir.
Sir, I am also audible.
Rafiq, are you ready for presentation?
Yes, sir.
Now you start your presentation.
Okay, sir. Good afternoon, sir. Good afternoon, everyone. I am Rafi Ramadana. Today I'm going to
Okay,
present
MLR
about
digital and hybrid computers.
uh,
But your
about
voice is not coming.
my voice is not coming,
Any
sir.
other student? You can hear the name of
Yes, sir. We
No,
can
yes,
hear.
sir.
Everyone
Rafi?
can hear.
Yes, sir.
सर आपने उसे म्यूट तो नहीं कर रखा है?
Hello, Kanchan Saxena. Kanchan,
यस सर.
are you audible?
सर बाकियों को उसकी आवाज आ रही है, बस आपको नहीं आ रही है.
No,
Sir,
no
you
one
are
is
audible. I
audible.
think your speaker is off.
Hello.
Hello, sir.
सर
Yes, sir.
Okay. Uh, now, Rafiq Ramadan, start your presentation.
Okay, sir.
Okay. Now, at this time, you are audible.
Okay. Good afternoon, sir. Good afternoon, everyone. I am Rafi Ramadana. Today I'm going to present about analog, digital, and hybrid computer. So first, there are three classification of computer based on the basis of data handling. They are analog, digital, and hybrid computer. In this presentation, we will discuss about the definition, examples, and other things about it. The first one is analog computer. Analog computers are designed to process analog data. Analog data is continuous data that changes continuously and cannot have discrete values. We can say that analog computers are used where we don't need exact values always, such as speed, temperature, pressure, and current. And analog computers directly accept the data from the measuring device without first converting it into numbers and codes, which mean they measure the continuous changes in physical quantity and generally render output as a reading on a dial or scale. The first use of analog computer were at the time of 1950s to 1960s. And here's some examples of analog computer. Speedometer, thermometer, analog clock, older weighing machine, radio, TV signal are examples of analog computers. And second one is digital computer. Digital computer is designed to perform calculation and logical operation at high speed. It accepts the raw data as input in the form of digits or binary numbers and processes it with programs stored in its memory to produce the output. All modern computers like laptop, desktop, including smartphone that we use at home or office are digital computer. The first digital computer was designed for numerical computation in the late 1940s. Digital computers give result with more accuracy as it is not dependent upon physical quantities for processing a task. There are mainly three parts in a digital computer and it consists of first input. The user normally provides the data to the device that is known as input. So the computer accepts input data from the user via an input device like keyboard. The input data can be characters, words, text, sound, image, document, and others. And next is processing. The input that is provided by the user is processed internally using some defined sequence, which means it performs some action on the data by using the instruction or program given by the user of the data. The action could be an arithmetic or logic calculation, editing, and others. The third is output. Once the processing is complete, based on the input, the output is displayed to the user. Or we can say the output is the result generated after processing of the data. The output may be in the form of text, sound, image, document, and others. And here's some advantage of using digital computers. It allows you to store a large amount of information and to retrieve it easily whenever you need it. You can easily add new features to digital system more easily. Different application can be used in digital system just by changing the program without making any changes in hardware. It offers high speed as the data is processed digitally. It is highly reliable as it uses error correction codes. Reproducibility of result is higher as the output is not affected by noise, temperature, humidity, and other properties of its components. And here are some examples of digital computers. Desktop, laptops, notebooks, smartphone, tablets, calculator, and digital clocks are examples of digital computer. And the last one is hybrid computer. Hybrid computer has features of both analog and digital computer. It is fast like an analog computer and has memory and accuracy like digital computer. It can process both continuous and discrete data. It accepts analog signal and convert them into digital form before processing. So, it is widely used in specialized application where both analog and digital data is processed. For example, a processor is used in petrol pumps that convert the measurement of fuel flow into quantity and price. Similarly, they are used in airplanes, hospitals, and scientific application. The first desktop hybrid computing system was the HighCom 250, released by Packard Bell in 1961. And here's some advantage of using hybrid computer. Hybrid computer is mixture of both analog and digital computer. It takes the accuracy of analog but speed of digital computer. It produces the quick and precise result. It has the ability to solve and manage big equation in real time. It helps in the online data processing. And here's some examples of hybrid computer. Petrol pump, electrocardiogram machine, monitoring machine, and ultrasound machine are examples of hybrid computer. That's all my today presentation. Thank you for your nice attention. Thank you all.
Okay, Rafi, nice job. Open your video.
Sir.
Yes, okay. Now close it.
Okay, sir. Thank you, sir.
Okay, thanks. Next one, Himanshu Yadav. Himanshu, are you ready?
Is
Now
my
share the screen and start presentation. Okay.
Good afternoon, respected sir, and all my dear friends. My name is Himanshu Yadav. Today I am going to present a topic on number system implementation. So, introduction. Every computer stores numbers, letters, and other special characters in coded form. Before going into the details of these characters and code, it is essential to have basic understandings of these number system. Hence, this topic familiarizes you with fundamental of number system. It also introduces some commonly used number system by computer professionals and relationship among them. There are two types of number system. First, non-positional number system, and second is positional number system. First, non-positional number system. In early days, human beings count numbers on their fingers. When counting goes beyond 10 fingers, then they use stones, pebbles, or sticks to indicate values. The counting method is known as non-positional number system. Second is positional number system. In positional number system, there are only few symbols called digit. These symbols represent different values depending on the position. The following three considerations determine the value of each digit in such a number. First, the digit itself. Second, the position of digit in the number. And third is the base of the number system. Now we describe some types of positional number system. First one is binary number system. In binary number system, the value of base is 2. It has only two symbols or digit, 0 or 1. Each position in binary number represent a power of base is 2. Bit bit is a short form of binary number. Hence, bit is computer terminology means either 0 or 1. Octal number system. In octal number system, the base is 8. There are only 8 symbols or digits from 0 to 7. 8 and 9 do not exist in this system. The largest single digit is 7, one less than the base. Each position in octal number system represent a power of the base is 8. Now, and third and last one is hexadecimal number system. In hexadecimal number system, the base is 16. There are 16 symbols or digits. The first 10 digits are 0, 1, 2, 3, to 9. The remaining 6 digits are A to F, representing the values 10 to 15 respectively. Hence, the largest single digit is F of 15, one less than the base 16. Each position in hexadecimal number system represents a power of the base 60. Thank you.
Okay, Himanshu. Now open your video. Okay, now close it. Next, Arpita Singh.
Yes, sir.
Okay. Are you ready?
Yes, sir.
Okay. Please share the screen and start presentation.
Okay, sir. Sir, is my screen visible?
Yeah.
Okay, sir. Good afternoon, sir. Myself, Arpita Singh, and today I'm going to present a PowerPoint presentation on the topic command line based operating system. Command line interface. Command line interface has been a great tool of interaction with computers until the video display monitors came into existence. CLI is the first choice of many technical users and programmers. It is the minimum interface a software can provide to its user. CLI provides a command prompt, the place where the user types the command and feeds to the computer. The user needs to remember the syntax of command and its use. Earlier, CLI were not programmed to handle the user errors effectively. A command is a text-based reference to the set of instructions which are expected to be executed by the system. There are methods like macros, scripts that make it easier for the user to operate. CLI elements. A text-based command line interface can have the following elements: command prompt, cursor, and command. Command prompt is a text-based notifier that mostly shows the context in which the user is working. Cursor is a small horizontal line or vertical bar of the height of line used to represent the position of character while typing. Command. A command is an executable instruction. It may have one or more parameters. Output on command execution is shown in line on a screen. When output is produced, command prompt is displayed on the next line. And this is a diagram representing all elements of CLI. Examples of CLI-based operating system. Unix. Unix is a multi-user time-sharing operating system. Ken Thompson and Dennis Ritchie developed Unix in 1970s at Bell Laboratories. It was the first operating system written in high-level language C. Earlier operating systems were written in assembly language, due to which they were system dependent. However, since Unix was written in C language, moving it to a new system known as porting it was much easier. This was an important reason for its popularity and availability on a wide variety of systems. 10 useful Unix commands. Man, display manual pages. Ls, list the content of directory. Cd and mkdir, change directory and make directory. Rm and rmdr, remove files and remove directories. Cp, copy files. Mv, move or rename files. Netscape and Linux, browse information on World Wide Web. Pine and Pico, email and text editing. Finger, get information about someone on Unix. Host, get info about host machine. The other example of CLI-based operating system is MS-DOS. It stands for the Microsoft Disk Operating System. It is an operating system for x86-based personal computers and developed by Microsoft. MS-DOS was the main operating system for IBM PC compatibles during the 1980s, from which point it was gradually suspended by operating system offering GUI, graphical user interface. MS-DOS has three layers: BIOS, kernel, and shell. And the shell contains the command interpreter. It has about 70 commands, which are partitioned into two categories: internal and external commands. Internal reside in the memory, while the external reside on the disk. 10 useful MS-DOS commands. CD, change directory. Dir, display info about files and directories. Copy one or more files. Del, delete files. Edit, view, create or modify files. Move, transfer files or directories. Run, change the name of files or directories, delete files or directories permanently, CLS, clear all the content on the screen, format, erase information from a computer drive. Advantages and disadvantages of CLI. The advantages are granular control of an OS or an application, more efficient management of a large number of systems, ability to store scripts to automate tasks, and basic command line interface knowledge can enable troubleshooting of network connection issues or resolving other system tasks. Disadvantages: GUI is more user-friendly, steeper learning curve associated with memorizing commands and syntax arguments, and different command used in different shell. Thank you, sir.
Okay, thank you. Now open the video.
Okay, sir. Mm. 1 minute. Yes, sir.
Yeah, okay. Now close it.
Thank you,
you.
sir.
Next one, Pragati Misra.
Yes, sir.
Are you ready?
Yes, sir.
Okay, now share the screen and start your presentation.
Good afternoon, sir, and my fellow batchmates. Myself, Pragati Misra, and I am here to deliver a presentation on topic SOP and POS techniques, where SOP stand for sum of product and POS stand for product of sum. They are two standard form of Boolean expression. All the Boolean expression can converted into either the two standard forms. Why do we need these standard form? Because standardization make the evolution, simplification, and implementation of Boolean expression much more systematic and easier. First, let's get to know about what is sum of product form. But before that, we should not get to know about two terms, min terms and max terms. Min terms, which is denoted by small m, are and terms with every variable present in either true or complemented form. Psi represents the sum of all min terms. There are two min terms for n number of binary variables. Max term, which is denoted by capital M, are all terms with every variable in true or complemented form. Pi represents the product of all max terms. There are two m max term for n number of variables that may appear normal or complemented. SOP form means sum of product form. A sum of product expression is a single product term, min term, or a several product terms, min terms, logically odd or added together. For example, x complement dot y complement plus x dot y complement dot z complement is a SOP expression.
Your screen is
This
not
is a
changing.
standard or canonical form of SOP, where f is a
Pragati,
function which is equal to x complement dot y complement dot z complement plus
Pragati,
x dot y complement dot z complement plus
Pragati,
x dot y complement dot z plus x dot y dot z complement plus xyz. This form written when the function is high means output is 1. In SOP form, a single overbar can't extend over more than one variable. However, one variable in a term have one bar. For example, x dot y whole bar plus u dot v is not allowed. But we can write this expression in this form: x bar dot y bar plus u dot v. The standard SOP form is an expression, one in which all the variable in the domain appears in each product term in expression. Here is a given example. SOP expressions are important in constructing truth tables and the coordinate map simplification method. These are the steps by which we can convert a Boolean function in its SOP form. Construct a truth table for the given Boolean form. Then form a minterms for each combination of variable whose output is 1. Then sum or odd all the minterms obtained, then we get desired expression in SOP form. SOP is also called disjunctive normal form. Let's get to know about product of sum form. A product of sum expression is a single sum term, max term, or several sum terms, max terms logically multiplied or ANDed together. For example, x dash plus y dot x plus y complement is a SOP expression. This is a standard or canonical form of POS. F is a function which is equals to x plus y plus z dot x plus y plus z complement dot x plus y complement plus z complement. This form written when function is low means output is 0. POS is also called as conductive normal form. Like SOP, in POS expression, single overbar can't extend over more than one variable. For example, x plus y whole bar dot y u plus v is not valid. But we can write this expression in form of x bar plus y bar dot u plus v. POS can contain single variable in an expression. For example, x dot x plus y plus z dot x plus y. A standard POS expression is one in which all the variables in the domain appear in each sum term in the expression. Here is a given example: x complement plus y complement dot z complement plus v complement dot x plus y complement plus z plus v plus x y z complement plus v. Standard POS expression is important in constructing truth tables and Carnot map simplification method. These are the following steps we follow to express a Boolean function in its product of sum form. First, we construct a truth table for the given Boolean function, then form a max term for each combination of variables that produces a 0 in its function. The desired expression is the product and of all the max terms. Thank you.
Okay, Pragati. Now close it. Open your video. Next, Siddharth Vajpayee.
Yes, sir.
Yes, sir.
Okay, now close it.
So is my screen visible?
Yeah.
Good morning, sir, and my fellow classmates. Today I am here to present on the topic types of translator. So, translators. Translator is a computer program that translates program written in a given programming language into a functionally equivalent program in a different language. Depending on the translator, this may involve changing or simplifying the program flow without losing the essence of the program, thereby producing a functionally equivalent program. The term is also used for translators between software implementations and hardware implementations, application-specific integrated circuits, microchip of the same program, and from software description of a microchip to the logic gates needed to build it. So types of language translator. There are mainly three types of language translators which are used to translate different programming languages into machine equivalent code. First is compiler, second is interpreter, and third is assembler. Now we're going to talk about compiler. So compilers. A compiler is a translator used to convert high-level programming language to low-level programming language. It converts the whole program in one session and reports error detected after the conversion. The compiler takes time to do its work as it translates high-level code to low-level code all at once and then saves it to the memory. A compiler is a processor dependent and platform dependent, but it has been addressed by a special compiler, a cross compiler, and a source to source compiler. Before choosing a compiler, the user has to identify first the instruction set architecture ISA, the operating system OS, and the programming language that will be used to ensure that it will be compatible. This whole process is called compilation. So how does a compiler work? High level programming language, which is the source code, goes to the compiler, and if there is no compilation error detected, this whole program is converted to object program, which is machine language program. So compilers have several advantages. Compiled program run quickly since they have already been translated. A compiled program can be supplied as an executable file. An executable file is a file that is ready to run. Since an executable file cannot be easily modified, programmers prefer to supply executables rather than source code. Compilers optimize code. Optimized code can run quicker and take up less memory space. The whole program is validated, so there are no system errors. Users do not have to run the program on the same machine it was created. Compilers have several disadvantages as well. So because the source code is translated as a whole, there must be enough memory space to hold the source code. The compiler and the generated object code, they also need to be temporary working space for the compilers to perform the translation. Modern systems either have enough memory or use virtual memory to hold all the data. Compilers do not usually spot errors. The program has to be compiled and run before errors are encountered. This makes it harder to see where the error lies. The source code must be recompiled every time the programmer changes the program. Source code compiled on one platform will not run on another. The object code is specific to the processor's architecture. Examples of compiler: Microsoft Visual Studio, compiler language COBOL. An interpreter program execute other programs directly, running through programs code and executing it line by line. It analyzes every line and saves it. An interpreter is slower than runtime code because it takes time to understand code, then to compile and then run it. Interpreters are written for multiple languages that function separately on different systems without having to recompile for each. Examples of this include Flash-based web programs that will run on your PC, Mac, game consoles, and mobile phone. So how does an interpreter work? High-level programming language, which is the source program, goes through an interpreter and one by one translation happens. And if there is no error detected in the program, the whole program is converted to machine language program, which is the object program. Interpreters have several advantages. Instructions are executed as soon as they are translated. Since instructions are executed once translated, they are not stored for later use. As a result, interpreters require less available memory. Errors can be quickly spotted. Once an error is found, the program stops running and the user is notified at which part of the program the interpretation has failed. This makes interpreters extremely useful when developing programs. Interpreters have several disadvantages as well. So interpreted programs run more slowly as the processor has to be wait for each instruction to be translated before it can be executed. Additionally, the program has to be translated every time it is run. Interpreters do not produce an executable file that can be distributed. As a result, the source code program has to be supplied, and this could be modified without permission. Interpreters do not optimize code, the translated code is executed as it is. Examples of interpreter: OCaml, list processing, and Python. Assemblers. An assembler is a translator used to translate assembly language to machine language. It is similar for the assembly language but active like an interpreter. Assembly language is difficult to understand as it is a low level programming language. An assembler translates a low level language, an assembly language, to an even lower level language, which is the machine code. The machine code can be directly understood by the CPU. Assembly language consists of mnemonics for machine operation codes. So assemblers perform a 1:1 translation from mnemonics to a direct instruction. So how does an assembler work? An assembly language program, which is the source program, goes through an assembler, and one by one, 1:1 translation happens. And if there is no error in the program, then this whole program is converted to machine language program, which is object program. Assemblers have several advantages. So very fast in translating assembly language to machine code as one-to-one relationship. Assembly code is often very efficient and therefore fast because it is a low-level language. Assembly code is fairly easy to understand due to the use of English like in mnemonics. Assemblers have several disadvantages. Assembly language is written for a certain instruction set and or processor. Assembly tends to be optimized for the hardware it is designed for, meaning it is often incompatible with different hardware. Lots of assembly code is needed to do relatively simple tasks, and complex programs require lots of programming time. Compiler. Examples of assembler: photon assembly program, FAP, macro assembly program, MAP, symbolic optimal assembly program, SOAP. Thank you, sir. With this, I want to end my presentation.
Okay, thank you. Okay, just open your video. Okay, now close it. Next, Akash Verma.
Yes, sir.
Okay, now share the screen, start presentation.
Good morning, sir, and my dear batchmates. Today, I, Akash Sharma, a student of University of Lucknow, would like to present before you my presentation on difference between internal and external commands used in MS-DOS. So, first of all, what is MS-DOS? DOS stands for Disk Operating System. This operating, this operating system was first widely installed operating system for personal computers. DOS controls the computer's hardware and provides an environment for programs to run. This system program must always be present when working with your computer. Next, what are DOS commands? DOS commands are simple instructions to perform tasks on files and directories and are very useful to Windows users. DOS commands are case insensitive. This means that commands are not case sensitive. So whether you write in capital format or small alphabets, it understands what your command is. The file is the area where we store a group of information or data. The collection of a group of files is called a directory. Mostly these commands consist of regular word-like words. For example, erase, copy, del, print, etc. Some commands which have many words are reduced to their short form, which are to be discussed afterwards. So next, why are internal and external commands needed? Internal commands are more commonly used and important to the operation and use the Windows operating system. By embedding them in command.com file, they can be quickly accessed and always available in MS-DOS and to Windows when needed. Because they are stored in command.com file, they can be easily accessed whenever needed, however needed. External commands are powerful. They help fix problems, improve performance, and perform other actions as well. External commands usually have higher resource requirements than internal commands. As we know, internal commands are stored in external internal commands are stored in command.com file. So external commands need some separate files where they can store. Keeping them in separate files separated from internal commands helps to reduce load on Windows. Separate from internal commands helps to reduce the load on Windows. They can also be added to Windows whenever needed by copying the external commands file to the computer. Next, types of DOS commands. DOS commands are usually divided into two types: DOS internal commands and DOS external commands. So first of all, DOS internal commands. Internal commands are built into operating system as part of a file called command.com that we already discussed. When you type an internal command, MS-DOS will perform it immediately. Because it is stored in command.com file, it will recall it fastly, immediately. All of the internal commands are part of the shell, which could be command.com or cmd.exe, depending on your version of MS-DOS or Windows, and are not separate files on the hard drive. As long as you can open a command line, you can run any of internal commands, including with your version of MS-DOS. There are some examples of internal commands. CLS, short for clear the screen. It is used to clear the complete contents of the screen and leave only a prompt. Ren, short for rename. It is used to rename files and directories from the original name to a new name. Exit. It is used to withdraw from the current running MS-DOS session. Del, short for delete. It is used to delete files from the computer. Copy. It is used to copy one or more files to an alternate location. Next is disk copy. It is used to copy a diskette. Next is type. It is used to display the contents of a file. Next is time. It is used to view and edit the computer's time. And next is mkdir or md, short for make directory. It is used to create directories in MS-DOS. Next is rd, short for remove directory. It is used to remove a directory. So now moving on to DOS external commands. These external commands are for performing advanced tasks, and they do need some external file support as they are not stored in command.com file. As we already discussed, they are not stored in command.com file, so they need some file support. So DOS external commands are required less frequently because the most common and the important commands are already stored in command.com file and are called internal commands, so they are required so more frequently. DOS external commands are required less frequently. These are reside on disk. There are also batch commands or batch files, which are the text files that contain a list of internal or external commands which are executed in sequence when the batch file is executed. Example, autoexec.bat gets executed automatically on booting. Some examples of external commands. Deltree, short for delete tree. It is a command used to delete files and directories permanently from the computer. Next example, find. It is used to find for the text within a file. Next example is Xcopy. It is a powerful version of copy command with additional features and has the capability of moving files, directories, and even whole drives from one location to another. Disk short for disk compare, compares the contents of a floppy disk in the source drive to the contents of a floppy disk in the target drive. Format, as you know from the name, it is used to erase information of a computer, diskette, or fixed drive. Another example, attrib, short for attributes. It is used to change the attributes of a file or files. Sort, as you know from the name, sorts the input and displays the output to the screen. chkdsk, short for check disk. chkdsk is a utility that checks the computer's hard drive status for any cross-link or any additional errors with the hard drive. Next is print. It is used to printing a file. And the last example is move. It is used to move files or directories from one folder to another or from one drive to another. Thank you. That's all for my presentation. Thank you, sir.
Okay. Now open your video.
Yes, sir.
Okay. Okay. Now close it. Akash. Next one. Srajan Srivastav.
Yes, sir. Am I audible?
Yes.
Hello.
Yes, you are audible.
Akash, can you please mute yourself?
Okay. Now start your presentation.
Yes, sir.
Srajan.
Just a second. Let me share this. Sir, is my screen visible?
Yeah.
Yes, sir. So, good afternoon, sir, and hello to my fellow classmates. Today, I will be presenting the topic classification of software in front of you all. So, let's get started. Classification of software is actually a subtopic which falls under the topic software. So, before getting into classification of software, let us see and understand the concept of software. So our system works on the two main components, hardware and software. Hardware refers to the physical component of the system, which is responsible for what we do on our system. But hardware cannot do anything on its own. It requires command. It requires us to tell it what to do, when to do, and how to do. And this requirement is where comes the software in hand. Software refers to the set of programs or instructions which tells the hardware or the system how to perform the task. And now after this basic idea, moving forward to on our next slide. Here I have put a label diagram which briefs us about the software classification. A software is firstly classified in two parts that are application software and system software. Also after this, system software can be divided into subcategories such as communication software, utility program, operating system, and translators. Translator is then divided into assembler, compiler, and interpreter. Now let's have a look on our system software. System software is programmed in a way to manage and operate the works of computer itself. So in simple terms, system software is designed to operate the computer hardware and to provide a platform for running the application software. Now we will look further into different types of system software, namely operating system, programming language translator, communication software, utility program. Now, coming to our next point, operating system. Operating system is a collection of programs which makes a computer to actually work. It is the software which makes it possible for us to run different programs on our system. It provides an environment to our system to perform different types of work. The operating system organizes and controls hardware and make it conveniently available to the user. OS acts as an interface between the application program and the hardware. Also, it helps other system software by providing the platform. Some examples of operating system are Microsoft Windows, Mac OS, Ubuntu, etc., etc. Now, coming to our next point, utility programs. Utility programs are also as important as operating system because they are concerned with the housekeeping jobs of our system. They are small, powerful programs with a limited capability. They are usually operated by the user to maintain a smooth running of the computer system. They carry out some housekeeping tasks such as file management, diagnosing problems, and finding out information about the computer, etc. Notable examples of utility programs include copy, paste, delete, file searching, disk defragment, disk cleanup. However, there are also other types that can be separately installable from the operating system. Now, next point, I would like to talk about communication software. Communication software is an application or program mainly designed to pass information from one system to another. It is the key component to interact between different systems in our environment. As we can see, when the coronavirus outbreak shut down offices, communication became one of the initial challenges that threatened business community. But with the adoption of the right communication technology, this obstacle has been overcome with ease. Aside from handling day-to-day messages exchange, communication software are used to conduct remote meetings like this one, which we are having in real time, and discussions in real time. They often feature enterprise-grade security over to infrastructure to protect sensitive data. They use VoIP. Now coming to our next point, translator programs. Translators are software used by programmers to convert program from one language to another. Translator is also classified in 3 points. First one is assembler. Assembler is a very basic type of translator. Is a program that translates a program written in an assembly language, which is basically a low-level language written in bit code, and then the assembler translates it into a machine code. Uh, it converts it in a language which our system can understand, and what uh, assembler is not very efficient to use. Now coming to our next one, compiler. Compiler is a program that translates a high-level language into a machine code by translating all of the code at once. It translates all our written code in our specific language into the machine understandable language all at once without any problem. Now coming to our next point, interpreter. Interpreter is a program for translating a high-level language that we use specifically for some use purpose. It translates a high-level language line by line, each statement in the source code and immediately performing the action. It takes one line and execute the action and keep this on until all the lines are executed. Next, coming to our point, application software. Application software are those software which are designed to help the user perform specific tasks. They are meant to perform basic tasks such as making document or making spreadsheets, and as well as specialized tasks such as graphical works or creating virtual reality. Some examples of application software are word processor, browsers, multimedia application, etc. Now, this was it for my presentation.
Okay,
Thank you very
Sajal.
much.
Close it and open your video.
Yes, sir. Am I, sir, visible?
Okay, now close it, Sajal.
Okay, sir.
Next one, Neeraj Misra.
Yes, sir. Sir, my voice is audible.
Yeah.
Okay, sir. So my screen is visible.
Yeah.
Okay.
Logic gates. Okay.
Good afternoon, sir. Good afternoon, everyone. Myself, Neeraj Mishra, and today I am going to present my presentation on logic gate. Now, let's start. First of all, what is logic gate? Logic gate is an electronic circuit that operates on one or more input signal to produce a standard output signal. These logic gates are the building blocks of electronic circuit in a computer. It means that combination of multiple logic gates of different types are often used to build electronic circuit in computers. Out of many types of logic gates available, here we shall discuss only some of the most important logic gate, that is AND, OR, NOT, NAND and NOR gate. Now first one is AND gate. AND gate is the physical realization of logical multiplication and operation. It is an electronic circuit that generates one out that generates an output signal of 1 only if all input signals are also 1. Now the two or more switches connected in series behave as an AND gate. You can see the block diagram symbol and the truth table in the next slide. Here, this is the block diagram symbol for AND gate. Here, two inputs A and B and a single output C, that is C is equal to A dot B. This is the Boolean algebra for AND gate. In the truth table, you can see when A and B both are low, then output is also low. When A is low and B is high, then output is low. When A high and B is low, then output is low. When A and B both are high, then output signal is high. Now the next gate is OR gate. An OR gate is the physical realization of logical addition operation. It is an electronic circuit that generates an output signal of 1 if any of the input signal is also 1. When two or more switches connected in parallel, then this behaves as an OR gate. In the next slide, this is the block diagram symbol of an OR gate. Here also two input signals A and B and a single output signal C, that is C is equal to A plus B. This is the Boolean expression for block diagram for OR gate. In the truth table, here A and B both are low, then output is low. When A is high, A is low and B is high, then output is high. When A high and B is low, then output is also high. When A and B both are high, then output is high. And the next gate is NOT gate. A NOT gate is the physical realization of complementation operation. It is an electronic circuit that generates the reverse of the input signal as output signal. It is also known as an inverter because it inverts the input. In the next slide, here this is the block diagram symbol for NOT gate. NOT gate always has a single input and a single output. Here the Boolean algebra for NOT gate is C is equal to A complement. That is in the truth table, when A is low, then output is high. When A is high, input is high, then output is low. In the next gate is NAND gate. A NAND gate is a complemented AND gate. That is, the output of NAND gate will be 1 if any of one of the input is a 0, and it will be 0 only when all inputs are 1. Block diagram symbol and truth table for AND NAND gate in the next slide. Here this is the block diagram symbol for NAND gate. Here two inputs A and B and a single output C, that is C is equal to A dot B ka whole complement is equal to A complement plus B complement. This is from De Morgan's theorem, that is A plus B ka whole complement is equal to A complement dot B complement, and second one is A plus A dot B ka whole complement is equal to A complement plus B complement. In truth table, you can see A and B both are low, then output is high. When A is low and B is high, then output is high. When A high and B is low, then output is also high. When A and B both are high, then output is low. Here the most important point, that is an AND gate followed by a NOT gate operates as an NAND gate. It means that we will make an AND NAND gate when we will add NAND AND gate and a NOT gate. And the next and last gate is NOR gate. A NOR gate is a complemented OR gate. That is, the output of a NOR gate will be 1 only when all inputs are 0, and it will be 0 if any input is a 1. In the next slide, you can see the block diagram symbol for NOR gate. Here the block diagram symbol for NOR gate, that is here the two inputs A and B and a output C, that is C is equal to A plus B ka whole complement is equal to A complement dot B complement. Here this is from De Morgan's theorem. In the truth table you can see when A and B is 0, also yeah, A and B are both low, then output is 1 yani high. And the when A is 0 and B is high, then output is low. When A high and B is low, then output is low. When A and B both are high, then output is low. Here, a most important point, that is an OR gate followed by a NOT gate operates as in NOR gate. That it means that we can make an NOR gate when we will add OR and NOT gate. That's all. Thank you, sir. Thank you, everyone. Thank you so much.
Okay. Okay, now open your video. Okay, now close it.
Thank you, sir.
Next one, Alok Bhaskar.
Yes, sir.
Okay, are you ready?
Yes, sir.
Okay, share the screen and start presentation.
Is my screen visible?
Yeah, binary arithmetics.
Yes, sir.
Okay.
Good afternoon, respected sir, and all my dear friends. Here I am going to present my presentation on binary arithmetic. As the name suggests, we learn to add, subtract, multiply, and divide in binary number system. So we all are familiar with that. We use binary numbers to deal with computer instead of any other number system. So the question arises, why we use this binary system rather than the other number system? Binary over decimal. So as we know, information is handled in a computer by electronic or electrical component, and electronic component operate in binary mode, can indicate only two states, on, 1 or off, 0. The system has only two digits and is suitable for expressing two possible states. In binary system, computer circuits only have to handle two binary digits rather than 10 digits, causing simple internal circuit design, less expensive, and more reliable circuits. Arithmetic rule or processes possibly with binary numbers. So here, binary addition. Rule for binary addition are very simple. That is 0 plus 0 is equal to 1, 0 plus 1 is equal to 1, and 1 plus 0 is equal to 1. 1 plus 1 is equal to 0 plus a carry 1 to next higher column. Here is an example to how we add two binary numbers. And binary subtraction. Rule for binary subtraction are as follows: 0 minus 0 is equal to 0, 0 minus 1 is equal to 1. We borrow from the last column. 1 minus 0 is equal to 1, and 1 minus 1 is equal to 0. Here is an example to subtract 0 1 1 0 from 1 0 1 0 1. Binary multiplication. Rule for binary multiplication goes like this: 0 into 0 is equal to 0, 0 into 1 is equal to 0, 1 into 0 is equal to 0, and 1 into 1 is equal to 1. Here is an example to multiply two binary numbers. Binary division. Rule for binary division goes like this. That is 0 by 0 is equal to divide by 0 error, and 0 by 1 is equal to 0, and 1 by 0 is equal to divide by 0 error. 1 upon 1 is equal to 1. As we know, in decimal number system, division by 0 is, in any other number system, division by 0 is meaningless. But in binary number system, it is possible. The computer deals with this problem by raising an error condition called divide by 0 error. Rules for binary division. Start from the left of the dividend, perform a series of subtractions in which the divisor is subtracted from the dividend. If subtraction is possible, put as 1 in the quotient and subtract the divisor from the corresponding digits or dividend. If subtraction is not possible, divisor greater than remainder, record a 0 in the quotient. Bring down the next digit to add to the remainder digits. Proceed as before in a manner similar to long division. Here is an example which follows the rules as in the previous slides. That's all. Thank you, sir.
Hello, now open your video. Alok. Alok. I am audible?
Yes, sir.
Okay. Okay, now close it. Next one. Niranjan Kumar Yadav. Niranjan, are you ready? I think not audible. Less audible. Okay, Niranjan. Now start your presentation. Your voice is not coming. Open your microphone. Your microphone is closed. Okay, now next one, Prince Gautam.
Yes, sir.
Okay, now you start your presentation. I think there is some network issue with Niranjan.
So is my screen is visible?
Yeah.
Good morning, sir, and my classmates. I am going to give a presentation on graphical user-based operating system. What is graphical user interface? Graphical user interface is an interface which allows the user to use the system efficiently if he had not used it before. This interface is called user-friendly. Graphical user interface is easier to learn than other interface like command line interface. Command line interface use textual commands, but graphical user interface commands are textual. That's why graphical user interface are easier to learn. Then moving on, components. Graphical user interface uses a combination of technologies to provide a platform so that user can easily interact with the system. Common combination of such technology are Windows icon, menu, pointer paradigm, especially in personal computers. Pointer paradigm uses a input device to represent position of pointing devices, interface and presents information. Pointer paradigm is represented with icons. It is example is mouse. Next is user interface. User interact with information by manipulating visual widgets that allow for interaction to the kind of data they hold. The widgets of a well-designed interface are selected to support the action necessary to achieve goals of user. Larger widgets such as windows usually provide a frame for main presentation such as web page, email page, etc. Small widgets uses as a user input tool. The next is three-dimensional graphical user interface. Several attempts have made to create multi-user three-dimensional environment and some are given below. Bum top, where users can manipulate documents and windows with realistic movements as they were physical documents. Zooming user interface ZUI is a technology that delivers 3D environment and it is used in science fiction films. Three-dimensional computing environment 3D GUIs are very useful in molecular graphics, aircraft design, computer games, etc. The next is comparison with the command line interface of graphical user interface. Commands available in command line interface are many, so complex operations are many. So complex operations can be performed using short sequence of symbols as compared to graphical user interface. Custom functions in command line interface used to facilitate access to frequent functions, but it is not available in graphical user interface. Graphical user interface can be made quite hard when dialogues are buried deep in a system or moved to different places. Command line interface are light-weighted as compared to graphical user interface as they only recall information necessary for a task. There are some examples of graphical user interface, or you can say graphical representations. The first one is Wayland Compositor. Second one is Mate. Third one is Gnome Cell, and the fourth one is KDE Plasma 5. Thank you. That's all my presentation.
Okay. Now open your video. Okay, now close it. Next, Manvi Kashyap. Now start your presentation.
Sir, is my screen is visible?
Yeah.
Good afternoon, sir, and my dear classmates. Today, I will discuss about logic gates and its application. Logic gates. Logic gates is an electronic circuits and that operates on one or more input signals to produce standard output signals. Logic gates are the building blocks of the electronic circuits in a computer. Types are often used to build electronic circuits in computers. Types of logic gates. Logic gates are divided into three categories: basic logic gates, universal logic gates, other logic gates. Basic logic gates are divided into three categories: AND gate, NOT gate, and OR gate. Universal logic gates are divided into two categories: NAND gate and NOR gate. Other logic gates are XOR gate and
Yes, Manvi, continue. Manu, are you Manvi? Are you here? Okay, Manvi, are you here?
No, sir, she left.
But his screen is not visible here. Manvi, can you hear me? Okay. Anybody other want to present today? Now, be attentive. I am going to take your attendance. Okay, Anchal Kushwaha,
Present, sir.
Aditya Jaiswal,
Present, sir.
Sharma, Akshat Jaiswal,
Present, sir.
okay. Alok Bhaskar,
Yes, sir.
Archana Yadav,
Present, sir.
Arpita Singh,
Present, sir.
Himanshu, okay. Then Kanchan Saxena,
Present, sir.
Sir, Astha Sthana present.
okay. Astha Sthana, हाँ ठीक है ओके. Next, Manvi Kashyap,
Present, sir.
next Meenakshi Sharma,
Present, sir.
next Neeraj Mishra,
Present, sir.
Ayush Mishra, Ayush Mishra,
प्रेजेंट सेल्फ मैसेज भेजा.
हाँ. Pragati Mishra,
Present, sir.
Prakash Chaurasia,
प्रेजेंट सर.
next Pransu Upadhyay,
प्रेजेंट सर.
Prince Gautam,
Present, sir.
Rafi Pramadhan,
Present, sir.
Rashi Rishi Srivastav,
प्रेजेंट सर.
Sachin Tripathi,
प्रेजेंट सर.
next Samant Mishra,
Present, sir.
next Shivam Tripathi,
शिवांश त्रिपाठी सर प्रेजेंट.
हाँ शिवांश त्रिपाठी, next Shreya Avasthi,
Present, sir.
Siddharth Vajpayee,
प्रेजेंट सर.
Srajan Srivastav,
Present, sir.
okay. Anybody other who have not got their attendance?
सर नीरज मिश्रा हो गए.
Manvendra Pratap, yes Manvendra Pratap. Any other?
सर नीरज
सर
मिश्रा.
मेरी
हाँ हो गया नीरज. श्रेया हो गया.
सर मेरी अटेंडेंस हो गई श्रेया अवस्थी.
Yes, yes.
ओके सर.
Rest of the student prepare your presentation and present tomorrow. Okay.
Excuse me, sir.
Yes, sir.
Rest of the student who have means those students who have given a presentation today, they can send their PPT on my email.
Okay, sir.
Okay. Okay. Now this is end of the class.
Okay sir. Thank you sir.
Thank you, sir.
Okay.
Thank you, sir.
थैंक यू सर.
Okay.